why we call smartphone compared with our conventional mobile phone? why we call smartphone?
I don't really know what comes next. I'm just doing my best, even though I'm so stressed out. Everything just feels like a test that I fail so depressed when I can't seem to get out. But something deep inside won't let me quit. I swear that I'm inspired by all this shit. Tell me that I can and I won't. That's what guides me the most. Won't you lie? I'll do what I want.
This kind of function, right? Once we say a phone to say the internet. Are you sure this is only me? Well, I think many students have different counter, right?
I'm inspired by thirst, I'm inspired by worth. I desire your worst, so you can just hide while I work. I ain't tired, you first. I'll write a second, third verse about the lives you go disperse. You never did shit, I know it hurts. Something deep inside won't let me quit. I swear that I'm inspired by all this shit. Tell me that I can and I won't. That's what guides me the most. Fuck your lies, I'll do what I want.
The same environment, right? And then so that, and then to do some proper response, right? In the old day, right? So that I will mention about this kind of lecture about what's the most sensor exists in the smartphone. Of course, in the near future, we say we must have much more this information, and so this is of course sensor. This kind of local sensor in your smartphone will be also gradually integrate what AI. Do you know that your most of this new smartphone you have AI, artificial intelligence, they embedded in this kind of smartphone process they call NPU. Okay, so NPU, why? NPU is neural processing. I think all the new smartphone, including iPhone 10 or something, have this kind of I say AI integrate with this kind of CPU processor, so that of course the AI most likely if you look at like iPhone 10 or beyond, so there's a NPU, right? Neural processing unit. Okay, so that this is something, and of course all the sensor in your smartphone much more, so that you have what? Sensor fusion. A lot more sensor, and then you can use a lot more function. And then so that's an additional processor. Every smartphone, those kind of processor has additional sensor hub function to process a lot more data from sensor, because your sensor has a lot more. Once you mention Yi-Kuen say AI and CPU identical. No. CPU is what? What is CPU? I don't have some idea. Central process unit, right? Is this for those computer for many years? Why? Most likely do some what? Computational work, right? But AI NPU is not. AI also NPU has AI has certain what? Certain kind of algorithm. AI, for example, deep learning, right? There's a family of deep learning. This kind of model will be embedded in those hardware. Like I would say, it's an ASIC chip. It's application. The AI and CPU are not the same. Okay, I say typical CPU is trying to do computational work, right, and process all the digital data, right, and then do things. But the AI is different. Really, most likely is process those kind of information, sensor data, or and then try to have sense, and just a human brain, right? You say our human have 5 senses, right? Eye, our ear, and mouth and nose. And touch. We send this information and our brain to process this kind of sensor data. Our human have 5 senses, and then we react to things. Do you say? So the same thing. So AI is very different, right? Okay, so that's something I don't know. So of course, you can easily look at, for example, all the like iPhone, new iPhone, they do have this kind of AI function. It's not just something more intelligent, I would say, more intelligent. This kind of, if you look at for example, iPhone 10, iPhone 12, so that all this advanced processor, they have now have this kind of unique the AI built in, and the requirement is very high. Requirement, that means that all these things require very advanced semiconductor technology. So that's why, like, so this is important, right? For all the advanced smartphone require a very advanced this kind of semiconductor manufacturing process for now to be, to have like 10 billion, right? 10 on the order 10 billion of this kind of transistor, right? Do the not only computational work, but also do this kind of AI and also communication. And I think there's a lot more this kind of thing. You see, so let's tell you, this is something. Of course, here we are not talking about this kind of a specific computer science, but at least you have some basic idea. Your smartphone is really advanced this kind of thing now. You see, so of course, not too many companies can really work on this kind of advanced this kind of smartphone process. Is really usually, I say, is probably has about, I would say, 700 engineers, or maybe even 1,000 engineers work together to develop this kind of advanced this kind of processor for smartphone. Is a non-trivial. Also need to put a huge amount of money so that you can really make a good design. This is a very challenging for this kind of advanced processor using smartphone. At this moment, only 7 companies can afford to make this kind of a smartphone processor. One of famous one is what? Qualcomm. Qualcomm, then of course MediaTek in Taiwan gradually make it much more advanced than this kind of smartphone. MediaTek in Taiwan used to make those kind of smartphone made in Shenzhen, right? So but now MediaTek is really has at least you look at the benchmark about MediaTek 5G processor. Actually, it's very advanced. It's almost close to the this kind of American, United States, this kind of Qualcomm's processor. Okay, so that's something I just tell you. This something is of course I just tell you this is a non-trivial, the same thing. Yeah. Okay. Anyway, I just tell you some basic concept. But anyway, so this I would say is one of I was very interesting topic for this kind of work. And then so that I just give you some for this thing. Or first we'll talk about what is a microsystem, microsystem or MEMS, and then talk about why it's so popular and also very important, and also can make a big money, right? And so that and also talk about history overview, and talk about current and future application, and also typical microsensor like pressure sensor, accelerometer, micromirror array, inkjet printhead, and also we mentioned about some sensor now in your smartphone, right? Of course, this micromirror array is also quite critical. I do have one PhD project now. It's important not only for next generation of computer platform. Okay, for example, VR, AR, MR, right? Facebook, now Meta, they have this kind of VR headset, Oculus, right? So that for this main micro mirror, also critical for this kind of VR, AR, MR, like Microsoft HoloLens 2. Okay, and also the MEMS micro mirror are also useful for what? MEMS LiDAR for self-driving car. So it's quite critical 3D sensor, right, for the robotics, automation. So that I do have supervised student on this thing, and then I do think it's quite critical for this kind in the coming years. I do, of course, there are series of company in Shenzhen and mainland China need this kind of technology, this kind of chip. I do every year China import about 200 billion to 300 billion of $, this kind of chip, right? Semiconductor chip. It's not only semiconductor, but also main sensor. Okay, and also these things. Okay, this main is difficult, but it's critical for many product. No, this kind of design and manufacturing, especially in Shenzhen. Okay. Well, one student mentioned about AI. So that again, I can see that AI it become reach critical this kind of maturity, especially kind of AI is more general, right? For example, deep learning is one of very popular in the recent I was 5 to 10 years, because it reached somehow critical this kind of maturity, so it can use for process this kind of one-dimensional data like our microphone voice, right? So that's why you have a smartphone can understand this kind of your voice, right? Our this kind of Alexa, as I mentioned about Alexa, is something also quite smart now, can understand, right? So this is one-dimensional data for voice, right? And also the two-dimensional data, image. When you take a picture, you camera small image sensor, then so all this is, I think, become very common in both, right? And all this kind of data means microphones send your sound and voice, human voice, become widely used in your smartphone, and why? So that's something. And also this kind of, I will mention about the fundamental concept of microfabrication, microscience, and other thing. Of course, well, I do welcome some of students who interested in this area. If you want to go PhD study or do some Europe project, so that I do have a group of PhD student postdoctor work on this kind of microsensor and main sensor work with energy, so that if you want to make big money, you want to definitely this area can enable some of our young students become the millionaire or billionaire. Okay, I'm not joking. So that, what do you think? What do you think? If you choose the right direction, so that you can become millionaire or billionaire, do you believe this area can make you very rich? Do you believe? I want to ask you. You want to become a billionaire? So this area is the right time. I'm not joking. It is one of our peer students, graduate from our UST, and both main one, the peer student, he got PhD, of course, more than 10, 15 years ago, and he does own company, main sensing. And then about more than 1 year ago, his company went to IPO. That's something is once your company become went to IPO, and then so that I just tell you, we do have our UST student now, because expert in worked on this thing and start his own company, are able to sing, and then so that they become super rich. So that it's, I'm not joking, but at least I just show you again, so that it's critical for you. I'm not talking about just technology. I talk about how you can become rich. This main sensing is again our student, our UST students company, so that really went to IPO and then become very rich. Of course, he also want to hire a lot of our students for his company, so that I welcome. I do have a group can notice our CEO of this main sensing. This is our students company. Okay, main sensing. So that his company went to IPO, and then so that it's public company, you can do a stock price, and then in Shanghai, so that he's looking for a lot more this engineer. So that anyway, so this is only one, but I told you a lot more. This kind of thing is very critical. All right, so that I do know a series of the main company in China, United States, Taiwan, anyway, so that globally, so that I'm not joking. So that if you want to get rich, this area is the area you can get rich. I'm not joking. So that as I tell you a thing, if you don't believe that, you look at this particular thing, and then so that the founder is Dr. Gary Lee. Okay, so it's from our student Gary Lee's company. Okay, so that I do have many years this kind of we know this our student. Of course, in the beginning it's very tough. I told you in the beginning very tough. He barely to survive, like when you start company like more than 10 or 15 years ago, but finally he's super rich. You look at the market capital and things, so that again his company is expanding, so that if want to work for this kind of important this kind of a microchip company, and then so that I do think it's opportunity for all of you to think about your future, think about if you want to get rich. Of course, I do a series of PhD students on this area. So that again, I just tell you something, not only, so it's a real, if I don't show you, right, this kind of IPO student, our USA student can then they don't believe, but at least I just show you this thing, and then our student become super rich. This is something is important, right? So that if there's no student, our USA student get the company become a public company and then super rich, then it's something when I talk here, then you will not believe, right? If I show you our Gary Lee is saying, of course, there's a series of a company in this area. I do think, especially this kind of big technology war between you and China, so that I do believe that the China government will provide a lot more funding for all the semiconductor, this main sensor company, start company, so that this is an opportunity for all of you to think about your future, right? So that it's something, of course, the good thing is that you understand this kind of advanced technology, and another thing is if you can really understand how to use this kind of sensor, main sensor, for new product, right? So that that's something is going to, of course, I also need to emphasize this kind of a mains motion sensor. It's not only accelerometer, but also what? Gyroscope, mains gyroscope, or G sensor. Every new smartphone, this one, combination of this accelerometer and gyroscope, we call the mains IMU, inertial measurement unit. So this is critical to enable this kind of new main sensor based unicorn. Our DJI, our another bank one, why they can make this kind of low cost consumer drone, consumer drone, why? Actually, it's also because our main sensor. Without our main sensor, our Frank Wang, our DJI he cannot become billionaire. Okay, so low cost, this kind of main sensor in smartphone is not only used for smartphone, also enable this $1 billion business. Okay, so that I just tell you, sensing this micro mirror, we will enable for this kind of I would say for this kind of main LiDAR for self-driving car is a critical to enable local self-driving car, so that you see all the big company, Google, Baidu, all American company, technology company, they put a lot of money in self-driving car in US, in China, or everywhere. So that this is something, and all the sensor is critical, enable this kind of new branch or new family of product, right? So that's something is quite critical here. Okay, so anyway, so that again, I show you what is a NAND. Basically, it's a Microsystem technology, sometimes called MST. It's more popular in Europe, and then of course, MEMS is a short name for micro electromechanical system, what they use in United States. And then we have micro engineering, sometimes used in UK. And then we have micro machine, or this kana in Japanese is also used in Japan. And of course, I have to emphasize Japan their semiconductor company used very strong, and unfortunately they didn't continue to have some new idea, new innovation, so that they actually their semiconductor especially manufacturing is left behind. But I think Japan to change the focus. They do have a change from semiconductor to this kind of microsensor. Why? At least there's several company like they really do a good business about this microsensor. For example, like Asahi Kasei, a company in Japan. They are almost the #1 in the world to make this kind of magnetic sensor or digital compass in your smartphone. So that I tell you something. So Japan actually is strong in certain kind of this kind of microsensor technology. Of course, I understand Japanese, and I read a lot this kind of there. This kind of this kind of sensor, microsensor is a paper and even a book. So that I tell you, and I know several this kind of big professor in this in Japan working on this area for a long time. Okay. But anyway, in Chinese, it is a thing. I tell you, this area is one of the important thing. And also, if you look at this kind, China has every 5-year national plan. Okay, so that in this kind of a 5-year national plan, and semiconductor and this MEMS sensor MEMS technology is one of important like direction. So the national priority to get this kind of funding for the university, for the company to work on this kind of semiconductor and MEMS. Okay, yeah, okay. Anyway, so typically here I show you MEMS is a study of making machine in micro scale with fabrication technique in IC industry, and the typical size range from micrometer to millimeter. Right, and the MEMS are system integrate sensing, actuation, computation, control, communication, and power. Of course, now I should say we should add one more. What should we do? AI. So that they do have this kind of MEMS, this kind of sensor. They have to AI now, machine learning. Okay, so this is another level. Why? So that of course also communication. That means we have IoT, right? Wider communication, internet. So that IoT, this kind of sensor, okay, it's quite important. And or AIoT, right? AI plus IoT sensor. That means your sensor has wireless communication function, connected to Wi-Fi, connected to 5G, right? And also another kind of low bandwidth, like this IoT communication system, right? In our UST campus, we do have a LoRa, right? LoRa, that means your communication have a most likely is wireless communication, right? You can think about this kind of Wi-Fi communication, 5G, and also what else? And then this kind of low bandwidth like LoRa. Our UST has this kind of LoRa. It's for low power. Low power, this kind of wide conversion for IoT system. So that the LoRa, okay, so that of course there's a family of wireless communication for IoT system and then AI. So anyway, I just tell you that at this moment, so that we're going to see this kind of integration thing. And then of course, if you think about this kind of MEMS integration, then of course, most likely MEMS have to integrate with what? Semiconductor. So that there's another branch of this kind of CMOS MEMS, right? So that here you can see sensor, sometimes sensor can be only pure sensor, but if you have complication of all thing, then you most likely, I would say, so this is another branch of CMOS MEMS technology, right? So how you use this kind of mature CMOS technology enable all the advanced CPU and smartphone process. And so that from my point of view, this kind of, if we can design this kind of microsensor using standard CMOS process in the industry, so that this will be very practical and enable real product, not just basic research. So that I tell you, this area is critical and important. Yeah, again, my research lab has been working on CMOS MEMS for since about 7 years ago, so that at least my lab can really design, do on design and fabrication of this kind of MEMS and CMOS MEMS sensor using our UST cleaning facility, and also using like TSMC, UMC, Global Foundry, even sense in Silicon Valley, this kind of foundry process to design and do and tap out, send our design to this kind of semiconductor company to make a chip. Okay, so that's something I tell you. This is something quite important. And of course, if scale down this kind of thing, then so that the traditional engineering, we're working on much larger. Typical size is about millimeter to 100 to 1,000. This kind of meter scale, and our micro machine typically is around millimeter 10 to the power minus 3 to about 10 to the power of minus 6 meter is about 1 micron. Okay, so that if you go this scale, and then so what happened? So that of course, if it beyond, then with some nano machine names, so that in this case is also critical for certain area. Of course, sometimes we may also try to think about how to make using nanomaterial, nanostructure on micro machine, so that it will be enabled to enhance performance of our MEMS device, MEMS or microfluidic or nanofluidic, so that of course all these are become more and more mature. Okay, and so that if you go into this kind of less than 1 millimeter, and then so that in this case you see on this scale, so we can look at this kind of DNA. Of course, cell is this. So that's why if you go into this area, so that our cell, what's the idea? How big is a cell in human or animal or plant? Huh? Any idea? How big is a cell, biological cell? In everybody, now all this kind of species, right? So that no matter animal or all this kind of plant with considered cell. So what's the typical size of cell? Huh? In your body? Huh? How big? Huh? What is the typical size? What is the typical size of a cell? Huh? In human body? Any idea? Probably nobody have a. Typically, I would say it's around on the order 10 micron. Wow, we have different answer. Some people say 10 power 9. Some people 10 to the power minus 3. Wow. So, well, at least I hope you have a basic biology concept. So we have a wide range of the answer. Wow, 10 to the power minus 3. So typically, I would say give you some rough idea, right? So that a typical cell in human, right? For example, I would say on the order of 10 micron. That's a typical size. Okay, so that on the order of 10 micron. That means 1 micron is 10 to 12 micron is 10 to 10 to the power of this kind of minus 6. So in this case, 10 to the power minus 5. It's a typical size for cell size. Okay, so this that means our micro machine is very interesting. Is on this on the size of this cell. Okay, of course, in human, right? Our typical like red blood cell is about 5 to 7 micron, and some of us cell in your skin a little bit bigger, on your 10, 15, 20 micron. So that the red blood cell, RBC red blood cell is around typical 5 to 10 micron. Okay, so that typical size. Okay, and a typical those skin cell a little bigger. I would say 10, 15 to 20 micron. Anyway, I just give you some rough idea of things, so that it is so that's why. Do you understand? So that once understand the size, effects, size, and then so you understand. So our micro machine will be useful for what? Biological application, biomedical application. So that for example, we can make a microfluid, microchannel, and for this kind of biomedical application. For example, I do have project how to make a microfluid device for cancer diagnosis. Why? Cancer cell is an cell. So, and also, of course, it going smaller, and what happened? When it goes smaller, then how about the DNA? Everybody, you have DNA. Do you understand? Every cell in the world, right? Nobody cell from human, animal, from plant, we have a DNA, right? So that how big is DNA? That's another English. How big is one this kind of DNA molecules now? In your cell, why you have a one DNA molecule? How big? Sorry, how big? One student say Yan say 10 to the power minus 8. Okay, so it's a DNA is a long chain molecule. Okay, DNA long chain molecule. If you look at the diameter, I think here I do show some picture, right? Didn't say. If you look at the thing and then, wow, one student say 10 to the power of minus 20 is too small. April, your number is too small. I just tell you, typically, it's I would say, I just tell you, it's something. Actually, I have make a 25 years ago. I make a micro channel to manipulate single DNA molecules. So that's why I do have some my own recent experience. So one single DNA molecule into the side diameter, right? Double strand DNA typically is a 3.4 angstrom. Double strand DNA, double helix strand. But the length is depends. Do you say? So that so if you look at so the diameter thing, so that here, if this is a diameter of DNA, about diameter, right? The D is around 3.4 angstrom. Diameter about 3.4 angstrom. Okay, 8 angstrom. And why? So that that means it's about 0.35 this kind of nanometer. Okay, so that is so here is around here. So it's quite very small. Okay, very small. But the length can be very long. Length. How about human DNA? So so that I just tell you, this is something is quite interesting about size fact. Right? So if under size fact, then you're able to think about how to do make this kind of a chip, right? Microchip, so that relate to the cell and DNA, so that we can do this kind of biomedical application. For example, we can analyze bacterial cell, right? Of course, virus. How about virus? COVID-19 virus, right? So typically it's very small, I would say. Okay, so that that's why this kind of micro machine and can be useful for biomedical this area, for this biosensor, and also microfluid for microfluid device for what? For cancer diagnosis, medical diagnosis, and also biosensor and biomens can be used also for DNA sequencing. Okay, and also detection of this kind of maybe COVID-19 virus. So I do, as I told you, I do have a project, ongoing project, about plasmonic PCR integrate with the semiconductor biosensor, using this kind of semiconductor function process. Anyway, I just tell you, this area is quite amazing and important. Biomedical definitely is a quite hot area and important now. Okay, yeah. And a great mention about this history. Actually, micromachine is not new at all. Micromachine exists for a long time, and then so that since invention of transistor, so that in 1958, actually we think about strain gauge. And then strain gauge actually is actually some kind of a sensor to make sure this kind of deformation of this kind of material. Why? Using in mechanical engineering or civil engineering, or basically it's some kind of sensor, strain gauge. It can be used for the building. For example, building this kind of multiple building is kind of deformation and thing, right? Displacement. So okay, so that you can see, and then of course people also think about silicon as a pressure sensor. You see, so it's all this is not new actually. You can see it's since 1950, 60, and but of course gradually, so we have seen a series of this kind of pioneer. Why you can see this inkjet printer. Inkjet printhead is also a 100 micro machine. Okay, it's mains actuator, and Dr. Kurt Peterson actually is one of pioneer in Silicon Valley. He founded a series of mains company, including also biomains company like Microprocessor, Sapphire company. Okay, so that and anyway, so that I tell you, there's a series of this kind of important milestone and thing, and also make this kind of a pressure sensor for blood measurement in the hospital, and then also make this kind of I think another quite interesting thing is how we can make some using this kind of semiconductor process to make this kind of micro motor, electrostatic micro motor, and then cone drive. This is also quite important. Cone drive is electrostatic mains actuator, and it's used in now every smartphone have this kind of cone drive for your sensor, mains motion sensor. Okay, and then of course in 1990, so there's a big push about this kind of US government, DARPA, provide the big funding to do research in this mains area. So that so this is quite important. So I don't know, do you have some idea about DARPA? DARPA is US this kind of DOD, research agency, provide funding, right? DOD, Department of Defense. So that this is one of advanced research project agency, right? So that the internet, right, this kind of thing was one of a project of DARPA in 1960, right? Now you can see we use internet, but of course in 1960, this kind of this Department of Defense, this DARPA think this kind of internet is very important, so that you see they really put this kind of money for research for very important technology many years ago. So that's why. Okay, and then of course DMD is also quite important. Digital micro mirror, right? And then now of course TI, Tesla Instrument, has been doing this one for 20 years and then become a real product. So now there's many kind of DMD used for what? For consumer electronics. Do you understand? Do you know that I always mentioned, for example, you can easily buy this kind of low-cost DMD-based computer projectors, or this kind of DMD-based this kind of head-mount display, and DMD actually can make a series of this kind of a product made in electronic product made in Shenzhen. You can easily buy those things from Alibaba, this kind of online, this kind of e-commerce website, Taobao.com and things. So that I told you this DMD become very critical for this consumer electronics like computer projectors and also a lot more. Okay, and of course this mains micro mirror and can be also used for biotechnology. Okay, and also be used for a lot more application. I do have project to make micro mirror for what? For low cost mains this kind of microscope, right? So that for bio application. And of course, we also see this kind of mains can use optic switch, also the VOA. I forgot I should put this kind of mains for it's for very important for optical communication system. Mains VOA, variable optical attenuator. Right? So that this is something it become a real product as an important component for this kind of optical fiber communication for internet. And then of course also iPhone, Apple had used this iPhone in 2007 as a G sensor. I think after that almost all smartphone have this kind of G sensor or micro accelerometer. Do you know that your smartphone do have this kind of very amazing this kind of a long list of this kind of sensor? Okay. Anyway, so here give you, and of course starting from this kind of early semiconductor fabrication, as I mentioned, so that those who invent transistor got the Nobel Prize, and then so that you can see, so that now we can see that the huge big progress of this kind of semiconductor. Why? So that you know, we can see in the past almost 40-60 years, so that semiconductor industry continue to push technology, make smaller transistor. So at this moment, of course, the TSMC is also #1 to make this kind of a 5nm transistor for your iPhone. So that this is all data, right? So that so this new iPhone, of course, they will use this kind of 5nm and 3nm for sure. Okay, so that Huawei used to can send their design to TSMC, but not anymore. So that but anyway, so those company can really leverage advanced company can really have a very good technology advance, so that after Huawei cannot use TSMC to make their smartphone processor, their business actually drop a lot. So this is something I tell you, this is non-trivial, okay, but it's critical. So let's see, and of course, everybody know that the Moore's law is quite important in the past almost 60 decades. So that every about 18 months, CPU power double, and also the you can number of transistors continue to increase like crazy. Why? So that the iPhone 10 we have about 7 billion transistor, while iPhone 12 we have about more than about 11 billion transistor. Why? This is something. Of course, the question is how about this kind of MEMS? What do you think? So unfortunately, at this moment, our micro machine is still cannot compete with this kind of thing to get this thing. So that it more looks like analog IC compared with this digital IC. Right? The analog IC typically is difficult to think. I would say MEMS, this micro sensor, is look like analog IC the chip. So that it's typically they don't use most advanced semiconductor technology, but the requirement is very different. So that you have to carefully design this kind of component, so that you can make a really good this kind of a sensor, microsensor and thing. So that to train student engineer how to design analog IC is at least 4 to 5 years. So it's non-trivial. So that at least I told you that we have this kind of trade war between you and China. So that and then China tried to ban this kind of semiconductor chip, right? Like Huawei and ZTE, they cannot buy semiconductor chip, and suddenly they get a big trouble, right? So that one ZTE in Shenzhen, actually, one of the big problem is they had to import NIC for their communication system, especially high speed, this kind of analog IC, so that it's very difficult to design to make. So that this area is really take a long time to train engineer. I do supervise PhD student who work on MEMS and also NIC design in at least 4 to 5 years. It's non-trivial, but they have a lot of demand. So that those engineers who are very expert can really learn real design and the fabrication of this semiconductor and this kind of IC have a lot more jobs. So this is something is non-trivial. But once you can really learn this kind of skill, there's many company will hire looking for this kind of engineer in semiconductor and this MEMS sensor. It's not only 1 or 2. Okay, so that as I told you, this is something is very difficult to train engineer. But once you can get this kind of a good experience and know how to do design and manufacturing of this, then as a many company is really want to hire this kind of engineer. So it's something of course it's a demand supply, right? If there's not too many engineer has a good skill, then it's clear that this kind of engineer has a very good market value, so that they easily find a lot more job. So this is something I tell you. This is something it's non-trivial, but it's a lot more job now. Why? Of course, I understand. At least more COVID-19 create big trouble, so that unfortunately, many people many companies may shut down. But in some area like this semiconductor or biotech, it's still booming, I would say. Doing that, so that I tell you, it's important for you to think carefully about the particular area, right? The field study you want to go, right? So yeah. Anyway, so here I just show you. There's another quite important area. ITRS is International Semiconductor Roadmap. So that so basically it's this is some industry they make this kind of roadmap, right? About more than 10 years ago or 12 years ago. So already clear show like the semiconductor industry continue to make smaller transistor. Now, as I told you, we go into 3 nanometer, while in mass production in Taiwan, TSMC, so that of course beyond this kind of Moore's law, we have more and more. I mean, it's going to make not only digital IC, but analog and also the sensor, microsensor actuator, and a microchip, biochip. So that this is something I tell you is quite important. So that at least more than 10 years ago, this semi industry, global semi industry, already make a big roadmap. So that I just tell you this is something is one of quite important in terms of semiconductor industry. So that of course beyond this thing, of course 3D integration, how in the integrate is kind of CMOS, right? Semiconductor with the kind of sensor, with biochip, with microfluidic. So 3D integration will be with wireless communication module. So be quite important, right? And next one is how semiconductor chip integrate with this kind of AI. I would say AIoT will be quite important, and also VR, AR, MR, and metaverse. Of course, this the next thing is I would say actually is the extension, right, of this thing. So this is something VR, AR, MR, and metaverse. This is another quite important. But all these things require this kind of semiconductor technology to enable this kind of new product. And here I just show you about say of this kind of main chip. And then this is not new actually. It's more than 10 years old. The ADXL micro accelerometer. And now your smartphone has even more advanced this kind of micro sensor, the major acceleration, and then TI, as you, why they make this kind of array of 1 million micromirror. All right, and at this moment, only this company in the world can make this kind of digital micromirror array. So that again, that's why this is one critical technology. Like there are several companies in China. They use TI, the chip, to make a product. If they don't, if the U.S. government try to ban this one, we have many several company will collapse, just like Huawei and this kind of GTE doing that. So that this is something I told you that again I have ongoing project on micromirror because the industry demand several company make a request. So that I do think in Shenzhen. So that I do think it's important for me to leverage my 20-year experience. I recently we have a big breakthrough to make a good this kind of design about this micromirror. Yeah, and we are file international patent for sure. Yeah. And anyway, so that here I just show you this area is quite important. And of course, there's another interesting. Not only this kind of microsensor, but also micro gears or something, or micro engine or micro component, right? So that this is just show you like micro gear to driven by this kind of micro engine is quite interesting, right? So that so definitely this is something they think this U.S. national lab think this can be used for enhance security of a nuclear weapon anyway. So that the MEMS is important for consumer electronics, the smartphone, but MEMS can be also used for what? For industry, smart building, smart construction, and also MEMS for this kind of military application. Okay, so that, and of course, MEMS continue to, okay, increase the new application and new market and bigger, right? And then so that it's all the this kind of thing, but tell you that we have at this moment we have a long this kind of sensor, right, which exists in your smartphone. Okay, so that I can see all these things exist in your smartphone. Okay, and see, and also we're going to have a lot more. Of course, I should say that there's another thing I didn't put down here is, for example, proximity sensor. Proximity sensor is another important sensor. Almost all the smartphone have this proximity sensor to sense what? Save power consumption of smartphone. That means if you close, now you face your face. Now look at you. If you look at your smartphone, and then they can detect, okay, you're using smartphone, and then if you don't use one, then they can try to make some proper adjustment of the light intensity of LCD display for smartphone save power. So that this is also quite important. It's kind of light sensor, come with distance sensor, measure distance. Okay, proximity so it's quite critical, and every smartphone have this one. Okay, so that this is something quite important. Of course, as I show you that you also have like a digital compass micromagnetic sensor, right? So that again, I'll show you. And of course, there's another branch of RF MEMS, radio frequency MEMS. Like actually, every smartphone have this kind of filter, FBAR filter, to process this kind of complication, this kind of system in your smartphone. So that it's kind of micro machine based, this kind of resonator, and they use as a filter, mechanical way to do some filter for this kind of thing. So that so this FBAR filter is one of very critical. Unfortunately, China cannot make this kind of FBAR filter for this wireless communication in. I say every smartphone have this one. Okay, smartphone have this kind of thing. I have this FBAR filter for wireless communication in your smartphone. Okay, but is to design to make this one is non-trivial. Okay, so at this moment, FBAR filter controlled by like US company and Japan only. So that this is another quite difficult thing. Okay, for China to make the product for make smartphone. And then of course we have seen the kind of main market continue to expand, right? So that we see this kind of not only inkjet, like in visual diagnosis, for example, now how can we make sensor for COVID-19, right? Pressure sensor, accelerometer, gyroscope, so all this continue to grow. Well, I'm sorry, this number is old, so all this one continue to grow. Now, I would say it's reached at least on this here, so that this is old data. But I told you, we have a lot more. This kind of all the sensor continue to reach the kind of billion of sensor was fabricated, especially for this kind of consumer, this kind of electronic consumer phones, smartphone, smart watches, and all things. And of course, we can see this market research show you in the past, for example, 1970, the first way is semiconductor. A second way we have display, like semiconductor is like human brain, and display like a human face, LCD or organic LED. And third way, starting from 2005, about as main sensor. Well, main sensor most likely is ear and eye, right? And your eye is what? Your smartphone has eye. It's a small image sensor, camera. Ear is a microphone, right? And touch sensor. You have your smartphone has what? Touch sensor, right? You human have touch, right? tactile, this kind of sensing, right? So that's all these things become quite important. How about the other? Human have 5 sense. What do you think? Now your smartphone, you have eye. Smartphone eye is a camera chip, right? Microphone is your ear. How about your human? This kind of noise and the thumb. Can your smartphone has additional duplicate the human 5 senses? What do you think? What do you think? Huh? Gradually, I can see will be implemented in the near future for sure. Huh? So in the future, the smartphone can duplicate all the human 5 senses. Huh? More intelligent to set environment. For example, I know there's one UK company, CMOS, this kind of gas sensor, to detect those kind, maybe detects CO2, carbon dioxide, detect CO, right? So that if you can have local CMOS, this kind of sensor detect the kind of concentration of this kind of CO2 for indoor air quality, or maybe PM 2.5 air pollution, so that actually I know some smartphone company in Shenzhen next to Hong Kong is trying to think about how to put additional this kind of sensor in smartphone, send this kind of CO2 or for indoor air quality, outdoor air quality. So it's something I do think all this kind of humans, this kind of 5 senses will be gradually implemented in the future. So that's why there's still a lot of more opportunity for all of you to think about this area. So that so not only eye, now ear, and of course touch sensor is every smartphone has touch sensor, right? Do you say? In old day we have a keyboard, right? Like BlackBerry, but after this kind of this touch sensor, right, invented, so that all this kind of smartphone we have no keyboard, we have this kind of touch sensor. So this is something technology. Also, it's also non-trivial, okay? And we'll show you current. We have all this kind of pressure sensor. This used for every car, for engine control. Disposable blood pressure sensor, accelerometer, used in airbag system in car, and then used for Wii, Nintendo, photo electron, iPhone, smartwatch, and what else? What else? VR, AR, MR. So all this motion sensor is critical for VR, motion sensor, VR, MR, AR, and MR. Okay, so this is metaverse. Okay, so that to sense human body motion, right? So that you can really try to adjust the kind of 3-dimensional video by doing that. So this is something I just say is continue to expand this thing. Anyway, our student, I do think some students play about video game with Wii or Nintendo, watching, of course, you're right. So that all this kind of video game console, right? We have this kind of Nintendo, Sony PlayStation, right? All this need this main sensor. Of course, I show you. I have one separate lecture talk about VR, AR, MR, right? So that this is all the sensor will be critical for VR, MR, and seeing application, right? In those micro mirror, like for example, Intel is not only making this CPU. Intel has MEMS LiDAR with micro mirror. Okay, so this I just tell you that Intel has this kind of interesting MEMS this kind of LiDAR with this kind of micro mirror. Why? So that this is something for what? For VR, AR application, for those HoloLens. I don't know you. Do you understand? So that all this thing will be quite interesting for you to think about this thing. Do you say? So that all this big company, they continue to work on VR, AR, MR. So that's one very critical thing. Why? So that of course DMD, digital micro mirror array for computer projector, and this is a moment. So this kind of micro machine sensor, this actuator enable a series of a company went to IPO. I told you in Shenzhen we do have I don't know, do you know, like we have several big company making this computer projector or TV in Shenzhen, huh? Jango, huh? I think you probably heard about this JMGO company. Have you heard about this company? Actually they use this kind of digital micro mirror for this kind of their product. This is the second largest company in China, and the first company actually went to IPO. Okay, about 1 or 2 years ago, the #1 company in Chengdu. Okay, and all this company need this kind of micro mirror technology from TI in United States. So this is something as a risk. If U.S. government try to ban this micro mirror technology, the chip, this company is going to collapse. That's why I am working on this kind of design and manufacturing R&D on this kind of micro mirror for this company. For not only company, they're serious company, they're using the DMD chip, so that it's something quite critical. Again, if you're interested, I tell you again, the biggest this kind of company went to IPO. Okay. Oh, April say why US would like to ban. Sometime, do you say that's a good question? One citizen, why US want to ban? I told you, semiconductor or this man is an important technology, so that if you use advanced semiconductor chip to make a product, you can add value. Your economic strength will be quite important. You say AI the same thing. AI, our semiconductor chip and main chip is one of not important technology to enable you become billionaire, enable you have a unicorn, make a much bigger now business. Do you say it's a really cool about economic technology, all the new technology, high tech, enable this kind of big money, make a big money. Do you say why? I think April asked a good question. So that unfortunately, at the moment, semiconductor technology and also our main technology is become national priority. Do you say? And so it's unfortunately this is something it wants to become national priority for US, for China, for all in Europe, so that in this case all the big country, they have to put huge amount of money to have maintain their technology advance. Otherwise, like Huawei, you see, and GTE, if you ban and then the whole big company collapse, huh? Do you say? So this is something unfortunate. Semiconductor technology and main technology is one of the national priority, huh? It's unfortunate, but that require, but it's non-trivial. It's non-trivial. You really could do work very hard, spend 4 years, 5 years to R&D, then finally you can really make do the design. It's something so that the US want to maintain their this kind of technology advantage, right? Economic this kind of advantage, so that in this case, if China can do all this semiconductor thing like Huawei, and then so that in this case from low end industry to high end industry, so that and US will lose the kind of the technology advantage and no economic power. You say this is something I told you. This unfortunately semiconductor is become one of quite critical now in this new century. If you look at one article from UK, right, economics, so that mentioned like in this century, last century, right, 20th century, one of this kind of important this kind of product is oil. Do you say strategic this kind of product is oil? Right, 20th century. The most important strategic this kind of product good is oil. It's oil. And this century, 21st century, Okay, so that the most important is not oil now. Strategic product is semiconductor chip. Okay, according to one article from UK economist. Okay, so that's something now it's a real truth. US this Joe Biden, so we want to put the 52 or 62 billion US dollar to gain the semiconductor this kind of manufacturing plan, and China put huge money, and TSMC put the huge money, 300 billion US dollar, why to develop advanced semiconductor this kind of chip. So this is something. Unfortunately, this is something once become this kind of national priority, so that and then if you have the technology, then your economy will continue to grow and become stronger and stronger. The same thing, AI, the same thing I told you. Combination of the semiconductor and sensor and AI, that is become also critical for to create a series of a big technology company, in the near future. Okay. Anyway, so there's a lot more this kind of application. I think, for example, mains inertial guidance for myself. Okay, so here, as I tell you, this looks like it used to be like aerospace engineering, but as I told you, this kind of thing is sitting in your mains IMU. It's in your smartphone. IMU used to be for aerospace engineering, but now it's for smartphone. Every smartphone has this kind of thing, low cost. Why? Also, self-driving car. Okay, it's critical. Why? And our drone, why? The DJI own. So all this, that's why this kind of low cost, high performance main sensor enable a list of new technology, new different business. Right? As I mentioned, if there's no mains motion sensor, we'll have no billionaire. Our student, our Frank Wang cannot become billionaire. Okay, so that's something. Same thing. I said that's why I told you, if you can really leverage kind of low cost microsensor for smart building, you can become billionaire. What do you think? Trust me, you see. All this advanced microsensor enable a loneless product. It's not just one incremental, but it's require a lot more effort to do engineering design. Why? So in the near future, what I would say, all these things is very important for smart building, smart car, smart system. Of course, we also have this kind of lab on chip microfluidics. I do have this kind of microfluid, this kind of technology become world technology and become a find international pattern, and then I turn this kind of microfluid this chip into a company for cancer diagnosis, so that we demonstrate our technology become world leading technology, can beat US company like Johnson Johnson, this kind of product, and also beat this kind of company in France. And saying that's why I told you that if you push this kind of technology very strong, and then so it can enable this kind of a series of good technology company, so that at least I just told you I really turn one of my this kind of technology become one lead technology and then file international patent, and this is important. And of course, biosensor is for food safety and COVID-19. I also have project, from the government for COVID-19. So here we should emphasize it's not food, but for our health, COVID-19. I have an ongoing project this kind of plasmonic PCR chip integrates biosensor for rapid detection of virus, but for DNA RNA, right, within 5 minutes. Okay, so that I told you this is something well, welcome. Some of you, if you want to do something, your project, please contact me, so that we are continue to hire a lot more people, especially PG student, postdoctor. I got the Hong Kong government's additional funding, $30 million, hire 40 postdoctor. to work on all the main sensor microfluidic things, so that the 40 postdoc is not small money, about 30 million Hong Kong dollar. So that I'm very busy to hire a lot more postdoc. Okay, so of course, if you want to experience something, so you're welcome to do some Euro project to work with my PhD or postdoctor. I'm hiring 40 postdoctor now with the funding from Hong Kong government. Okay, so that of course I do have ongoing COVID-19 project. Yeah, so this thing. So if you're interested to help work as a UG student helper or Euro project or student helper to make some money, of course I do have money to hire you as UG student, UG, I think that's all possible, right? So that if you are very energetic, so that you want to make some money, and I have money, $30 million to hire postdoctor, so that you're using, of course, unfortunately, your UG student researcher has some minimum cap. I cannot give you. Do you know how much for a postdoctor? For Hong Kong government funding, one postdoctor is 32,000 Hong Kong dollars per month. I need to hire 40 postdoctor, and for UG student, there's some minimum allowable this kind of thing, maximum. But anyway, I tell you, I have money. If you want to make some money, contact me. I will work with my PhD. I have $30 million. Anyone want to make some money? Work with my PhD and postdoctor. I have too much money now. But most likely hire postdoctor and say 40 postdoctor, $30 million. Anyone interesting? What was my PhD and postdoctor? So please contact me, so that all this thing and critical, of course, to save people's life. What do you say? COVID-19 is something, that's why government give me the money. So with technology, we hopefully we can really make a working prototype. Why? We have every day we have 200, 300 people die, and every day so many people, so that how to rapid detection of the COVID-19 is critical now. So that's why I push my PhD and postdoc work. Make sure, I think we almost can work for first prototype, but still we need this kind of additional manpower, so that again, if you're interested, please contact me, so that I'm interested. Of course, I ask my PhD and postdoc give you some assignment. Even if you work home, it's okay. Okay, you can do something. Anyway, so there are long range of different kind of this kind of MEMS can use this kind of MEMS filter, right? I show you EPA filter, right? It's quite critical. Every smartphone have this kind of thing, but unfortunately, almost no company in China can make EPA filter. This is also billion-dollar business. Okay, so that at this moment, like HP company, it dominate this kind of thing. So every smartphone have EPA filter. So it's a billion-dollar business. Unfortunately, no company in China can make. So this is something I tell you, but it's non-trivial. It's really non-trivial. Okay, so that and then with power MEMS and medicine, why of course all this become quite critical. Okay. Anyway, so that again we have traditional use of MEMS, right? Like here, as I show you, like we have a Microsensor for engine control, right? And also a MEMS motion sensor, stability control, of course, and then airbag system, right, for safety. And of course, in the near future, as I show you, another critical technology enable self-driving car, as I mentioned, is this kind of MEMS LiDAR. Again, I do have PhD work on this thing, so that this is very critical, but also non-trivial. Of course, I want to work on CMOS MEMS LiDAR, how we can use more low-cost way, right? Using TSMC CMOS process is something, again, I have ongoing research here area. Yeah, it's a critical enable a new product, self-driving car. Yeah. And of course here, now we have a lot more sensor. in your every car. Every smartphone have about 10 to 20 sensors, and every car has 50 or more. So that I tell you that you should understand, so that we're going to have smartphone. Smartphone is first milestone, and we have a smart car, smart building. All this is sensor AI will be critical for this kind of new family of product. This is something, and of course we have seen all this kind of MEMS exists and everywhere, right? Even inkjet, right? And also here for gene chip of microfluidic, for MEMS microphone and MEMS optic switch, and a lot more, I would say. Yeah, and everybody knows we have iPhones, all the smartphone, and video game console and DMD exists for all the consumer computer projector and TV, all right, and TPMS. This is also required by this kind of a US government. Many new car, they have to, every car, they have installed this kind of sensor, pressure sensor for monitoring about tire and for enhanced safety. So this is something also quite important thing. And again, so that as I mentioned, this before you can easily find, right, like a series of company really use this kind of like a Jingo, right? Jingo, and then so that if you look at this, there's a long list of company in Shenzhen or China. Jingo is second largest company make this kind of using digital microarray. And if you look at Taobao, and then you can find this kind of a DLP chip, and so that that something is quite important. And so that of course it's, but again, I tell you, it's also non-trivial to make this kind of DMD chip. So that I just quickly show you about this thing, so that if you look at this website, and then you find this many small shop now on Alibaba, Taobao, selling this kind of DLP DMD chip, but only one company, US company can make. So that is something, unfortunately, is very difficult. So that I just tell you, so that that's why I have ongoing research on this digital micro mirror, because it enable a series of this kind of company new product. So it's non-trivial, but it's important. We see that there's several companies request me to work on this kind of a micro mirror. No, again, so this is something I just tell you, this is quite important. Okay, all the smartphone had a lot more sensor, right? And here they show the Qualcomm. They show, you see, well, a long list of this kind of sensor for smartphone. Okay, not only MEMS, accelerometer, magnetic sensor, gyroscope, ambient light sensor, project sensor, touch sensor, fingerprint sensor, and humidity sensor, and also a lot more health. Why? So I can see this is something is quite important for all of you to think about. I think, of course, this all kinds of, all the smartphone sensor enable what? New application, new product. So have series of this kind of smartphone app use sensor. For example, we have a, I don't know if you play some of the video game, smartphone games, so that you also have this kind of thing. Of course, all the sensor with smartphone, we have seen this kind of thing will be seen. Okay, so that okay, anyways, we almost run out of time, so that the student asks about which chapter would cover in the midterm. Typically, I would say our midterm, the content midterm will cover from the beginning to about 1 week before the midterm. Okay, so that's a typical way so that our midterm will be held on 29th of March. I put according our schedule, so that our content for midterm usually is 1 week before. That means material probably to that means anyway. So I told you that's a typical thing. All the material will not cover this content, right? Like because it takes some time to study, digest. So that's a typical thing. Of course, I will make an announcement on our Canvas website to tell you, and I already asked the TA to provide this quiz and also give you some example to do some practice. Okay, so okay, I think that's it for today's lecture. So do you have any question? Again, if you want to make some money, please contact me. Of course, I'm most likely hire this kind of postdoctor, and then, but of course, I do have money to hire you as student helper. So that one student as again will be sample paper and past paper. Yes, I will STA to post this kind of a sample paper on campus website. Okay, okay, and then I hope you can stay healthy and then follow the general guideline we mentioned on our campus website, so that keep you healthy. So that what is one of very important. So that the number of new complaint case still increasing. So that I do hope of you take good care of yourself. So that again remind you about all the basic things to protect yourself, your family member, and that's the important thing now. Okay, okay, bye bye, bye bye, bye bye. Good luck.